So let's solve LeetCode 235 today, even though it says it's a medium difficulty question. If you, oh my god, if you understand the logic behind it, it will only take you like, it's just 2 or 3 line of code. So basically what they want from you here is that they want the lowest common ancestor. So what is the lowest common ancestor? Well, let me just show you the example and you will understand. For example, here what do they give you as input? They give you the tree itself, and with that they give you two nodes. Here you have p node, and here you have q node. What you have to do is you have to return the parent node that contains both p and q. For example, here we have p is 2, so here is p is 2, and q is 8, so here is q is 8. So the answer is going to be 6. Why is going to see the answer is 6? Why is the answer 6? Because 6 both 2 and 8 is under 6. That's why 6 is the answer. Now one thing to keep in mind is that look at this, something they told in the question is that where we allow a node to be a descendant of itself. What does it mean? It means that a node can be p and q can be answer itself. Let me explain you here. For example, in example 2 you have p equals to 2 node and q equals to 4. So here you have p which is 2, here you have q which is 4. So what will be the answer? You might think the answer is going to be 6, but no, the answer is going to be 2 itself. Okay, see, the output is 2, the answer is 2. Why? Because 2 itself contains both 2 and 4 under it. So this is going to be the answer. So now that you have understood the question, just think about the situation we can get in this question. It's actually very easy. If you just understand how a binary tree works, it's really easy. So just think about how a binary search tree works, BST works. In BST, you will always have a node will have in its left it will have a value which is going to be less than it. For example, here you have 6, and here you have 6, here you have 2. 2 is less than 6, and in the right side you will have value that is more than the node. So here you have 6 and here you have 8. So 8 is more than 6. So now you have to leverage this concept of binary search tree. So what will you do? It's actually very easy. If you see that p and q both are less than the current node, so you will just go left. For example, here you have p equals to 2 and q equals to 4. So in our current node we have 6. So both 2 and 4 are less than 6. So we'll just go left. We'll go left. And let's say p was 8 and q was 9. Okay, then what we will do, we'll just go from 6, we'll go to the right. Why will we go right? Because of course, like both 8 and 9 is greater than 6, so we'll just go to right, because every value in the right is going to be more than 6. That's how we will just use recursion to get the answer. And without that we'll get the answer. Let's just say if it happens that one value is let's say greater than the current node, and one value is less than current node. For example, here if we go from 6 to 2, okay, then we have p equals to 2, q equals to 4. So 4 is more than 2, q is more than 2, but then p is equals to 2. So 2 is going to be answer itself. Even just if you just look at the first question, here you have p which is less than the current node. Here you have q which is 8, which is more than the current node. So 6 is we can just return the 6 as answer, and it's going to be the same way all the time. Just we have to update we have to use recursion. If the both nodes are greater than the current node, we will go right. If the both nodes are less than current node, we will go left. That's all, nothing more. So since I explained it, now let's just go to the code itself, and it's really easy. All we have to do is, if the value of root is, let's say it's greater than p, and also it's greater than the value of q. Then just all we have to do is we will have to make root equals to, let's just, this is a big word, I'm just going to copy this. Oh no, I made a mistake. And then root equals to root, we have to go left, and we are going to give p and q as they are. So this is for one side, and then we will have to basically do the same thing for right as well. If root and value, the value of root is less than the value of p, and also the value of q is less than the value of p, root, we'll just go right, and then we'll just return the root. So yeah, that's the code actually. Let's just submit it and watch. So as you can see, it just worked fine, and this is the most optimal way. There isn't any better solution for this, and it just takes log o log of n time, right? Because every time you are going right or left, you are just leaving off half of the tree. So yeah, I hope it makes sense.